Hello students, welcome back to the channel. Welcome back to the continuation of our previous upload that I had made on the channel as it relates to the 2024 end of year exam that was conducted on December the 18th. If you have not watched that video as yet, which is part 1 where we went through section 1, you will find a link pinned in the comments and also in the description of this video. Be sure to check that out before you proceed into this one. Now, this particular paper, the questions were, of course, a variation of past paper questions from the year 2004. It's just a mixture. I changed up the wording a little bit, and I also changed up the way that the questions were asked back then, just as to prepare these students and to see exactly where they're at the end of 3 months. Now, my channel primarily focuses on preparing Csec students, that is the Caribbean Examination Council students that are doing crash course mathematics over the course of 8 months, and for some students they are trying to get the results over the course of 3 months. So these particular papers are papers that are designed, the questions are designed with one intention only: to give the students the best approaches towards solving questions, just like these ones are questions of similar nature. If this is the first time here on the channel, do not forget to hit that subscribe button below. Of course, turn on your post notification bell to be notified weekly. In fact, to be notified weekly whenever I post my live classes. If you are in fact interested in getting access to joining these classes wherever you are in the world, as long as you desire and your aim is to pass your Csec mathematics course in a very short space of time, then all my details will be pinned in the description box below. You can contact me directly on WhatsApp, or you can join my Facebook group, you can join my WhatsApp group, you can join my WhatsApp channel to be notified whenever I post weekly. You can follow me also on Instagram, and you can follow me also on TikTok, where you will see behind the scenes of myself rapping and having fun with my students as we prepare for exams. Now, of course, in part 1 of this upload, I was able to go through questions 1 through to 4, and it was quite an interesting video. You know, at the point of making this video, which is in December, I'm going to be releasing this video on January the 7th. So obviously, if you're watching this video, you've made it to 2025. And with that said, I want to take the opportunity here to wish all my students and potential students a happy new year. Of course, it is that time of the year where students are in full preparation mode. We have a lot to cover. We have covered a lot, but we have a lot to cover. So there's a lot that's going to be posted here on the channel. Of course, you feel free to follow me on all social media platforms. So without further ado, let's dive right on into what this section of the video is about. Now, as you can see here on screen, we are currently at question 5A. And in this section, students were given the option to choose either question 5 or question 6. And as I stated earlier, at the time of making this video, I do not know what the results are at the moment. So I can't make a reference as to what mistakes students would have or shouldn't have made. So let's dive right on in here and let's bring this video to the end. Here we are looking at the diagram below, which I'm going to be pulling up on the screen in a second. The diagram below is a bird's eye view of the plan of a building with dimensions as shown below. Your task is to use the information to calculate 1, the length of RS, state the value of X. You're to find the area of the entire floor. You're also required to find the perimeter of the floor. And of course, that's the last part here that I added. Both floors are to be covered with flooring boards measuring 0.2 meters squared. What would be the total cost of tiling both floors if the flooring board costs $38.25? So this is a really nice question that will test various aspects of the fundamental aspect of a student's measurement ability. So let's pull up that diagram on screen here. So the diagram that we have here on screen, this is section 2. So this is the bird's eye view of the building. So pretty much we're looking at the building from the top. And so what we're looking at here is we have this section here at the top, which is 10 meters. Then we have to the side here, we have 5 meters. Then we also have 2 meters here. We have 3 meters right to the side here. We have 8 meters down here. And we have this missing side that is X. So we're going to have to use some critical thinking in order to... Now, this is not a very difficult question, but it depends on your ability to think outside of the box as well. So here, the first thing that we're asked to do is to calculate the length of RS. Now, RS is this broken line right here. And so RS seems to be parallel to the side that has the dimension 10 meters. It is parallel. Now, usually when you're finding the length of a side, or you're finding a missing length, or you're finding something that's missing, you've got to look for another side that is parallel to the side you're looking for. Now, RS is parallel to 8 meters, and it's also parallel to 10 meters. Now, the reason why we can't use the 10 to find the length of RS is because we don't know nothing about the missing side that is attached to RS. Now, if we compare RS to 8 meters, you will find that RS and this meter right here, that's 2 meters, they add up together to give you the 8. So therefore then, we can safely go ahead and create a little equation here. We can say RS plus, so we can see RS plus the 2 meters here, so RS plus the 2 meters will give us the length of 8 meters. So if we can do that, then it means that we can use a basic equation here and transpose the 2 meters to this side. So we can say RS then is equal to 8 meters minus 2 meters. And that is simply going to give us an answer of 6 meters. Pretty simple. All right. So that's how you have to approach these questions in the future. Whether it be a very simple composite diagram like what you're looking at, or you're looking at a more complicated diagram, always look for sides that are parallel. Now we are then asked to find, or we are asked to state the value of X. Now notice that X is parallel to the 10 meters at the top. X is not connected to the 8 because the 8 meters stop here and stops here. So X is outside of that measurement. Now we have to make a comparison between the X and the 10. Now notice that we did in fact find 6 meters here. So we can't forget to remember that sometimes the answer that we find in the previous question is usually the answer that's going to help us to find whatever else comes after that question. So in this case here, we can also form a very simple equation. We can safely say then that X that we're looking for plus the 6 meters that we just found a second ago will be equal to 10 meters. And a very basic simple equation here, we can just transpose the 6 meters to that side. So X then is equal to 10 meters minus 6 meters. And then guess what happens? X then works out to be 4 meters. So we can just take that here and put that 4 meters. We can just simply erase the X here. And we can then therefore just simply put 4 meters here. All right, very simple enough. All right, so now that we have that information, it seems like we have everything that we need. Let's then move on to finding the area of the floor. Now, when we talk about the area of the floor, for all my fundamental students or students that have been struggling with math for a very, very long time, there are some very basic concepts that you should know, but you don't know. So, of course, the aim of this video is to try to make everything as easy as possible. So, when we talk about the area of the floor, what we're talking about then, it is in fact going to be how large is this space that I'm shading here. All right. Now, when we look at this, what we call in mathematics a composite diagram, it is not a shape that has a name, but because it's a composite shape, usually these composite shapes are made of two different or two of the same shapes. So it is clear then that we can say that this shape at the top, which we're going to be labeled as A, is a rectangle. And then this shape at the bottom here, which we're going to be labeled as B, is also a rectangle. So this then brings us to the idea that, okay, rectangle A, so let's do that here. Let's go ahead. Let's do rec A plus rec B will give us the area of floor. Okay, so all we need to do then is find the area of rectangle A and find the area of rectangle B and add it, and we should find the area of the floor. So the area of any rectangle is going to be length multiplied by width plus, again, length multiplied by width. So let's look at rectangle A then. The length can clearly be seen as 10 and the width can easily be seen as 5. So we can therefore then go to our calculation page here and we can say, okay, rectangle A is going to be 10 multiplied by 5, and that's going to give us 50 here. Okay, so that's 50 squared meters. All right, and we're going to add that then to, let's go back to rectangle B. Now, rectangle B, the length we're going to be using as 8 and the width is going to be 3. So therefore, that's very easy. It's going to be length times width, which in this case is going to be 8 multiplied by 3. And that's going to give us 24 squared meters. And so very easily then, if we add 50 squared meters plus 24 squared meters, we'll find out that our final answer here is 74 squared meters. So you can see it's not a very difficult question. It really comes down to your ability to think outside the box, be able to see through the questions. And the more of these type of questions you do, boys and girls, ladies and gentlemen, is the better you're going to become at it. But if you can only do one question and leave it at that, then you will find that when you get a similar or a different question that requires different type of calculation, you will find that you're going to struggle. All right, so hopefully I was able to give you some clarity on how to approach that particular question. Let's then move on to finding the remaining measurements here. It did say that we should find the perimeter of the floor. Now again, I know that sometimes when you guys are doing exams, you get a little bit nervous, you didn't practice enough, or you don't have enough knowledge. Perimeter means the distance around the edge of that particular shape. And like I said, the shape could be a standardized shape like a square or rectangle or a triangle, or it could be a composite shape like what we're looking at here. So what we're looking at then is finding the distance that goes from here down here to this side here, around here, come back to here, come here, and come here. So all we need to do is just add up all these lengths. Now there are some missing lengths here that we need to find. Now we do have this side here, which is 10 at the top. Now this side here is missing, but because it's a rectangle, one of the properties of a rectangle is that the opposite sides are equal. So automatically this side over here is going to be seen as 5 meters as well. Alright, so we have this 10 at the top, we have this 5 at the side, we have this 2 that is running parallel to the 10, then we have 3 coming down towards the side, then we have 8 at the bottom. Now notice that this side over here is missing as well. So once again, since rectangle B, since the shape at the bottom is also a rectangle, the property of a rectangle also stands firm, that the opposite sides are also equal. So this side here is going to be 3 meters. And remember earlier when they asked us in, I believe it was part 2, to find X, we had found that this side is actually 4 meters then. All right, so simple enough. Let's grab our calculator. Let me see if I can find my calculator here. Instead of writing it down on screen, just work with me, guys. You can have your calculators out as well to verify. It is 10 plus the 5 to the side, plus the 2 below the 5, plus the 3, plus the 8, plus the 3 at the side, plus the 4, plus the last number to the side here, over here, which is 5. And if we add those together, we'll find then that the perimeter of this actual shape here is going to be 40 meters. All right, so you would actually show the working out on paper as opposed to just writing it down like this, because as you know, most examination paper like when you show the working. All right, but okay, you'd still get the full marks if you had written down 40 meters here. All right, and then now finally then we had this additional question here, and this is where a lot of the students that I have taught over the years, and I've been teaching maths for a little bit over 12 years, I find that a lot of students who are doing crash course mathematics, whenever they land in a class that requires them to think or to read and interpret, they tend to break down a little bit. All right, and this is just based off experience alone that I'm talking about. So my experience tells me that whenever a student gets a worded question where there's now saying that both floors are to be covered with flooring boards measuring 0.2 square meters. Let's break that down. We're thinking about tiling the floor. All right, flooring boards, tiling the floor. So it doesn't necessarily have to be like a building, even though in this question it is a building. It could just be a case where you have this section that you need to basically put flooring boards out. So basically what we're going to be doing here is drawing the flooring board. In fact, I think I already drew the flooring board on one of my pages. Hold on, give me a second here, guys. So here we are. I did in fact draw my flooring board. So this is my flooring board. This is one piece of flooring board, and the area of this flooring board is 0.2 square meters. Now the cost of one of the board is $38.25. In order for me to know how many flooring boards I will need, I need to find out how many of this flooring board can fit exactly into the full area of the floor. Now remember earlier that we calculated that the area of the entire floor was 74 square meters. Let us double check on that calculation so we don't rush. Let's go back to question 1. It said that, well, not question 1, I believe it was question 3. It says down here that the area of the floor, here it is, area of the floor, we calculated that to be 74 square meters. So since the full area is 74, all right, and one flooring board is 0.2, it is very straightforward that we should divide the 74 by 0.2. They're both of the same unit of measurement. So if we go ahead then and we say 74 divided by 0.2, let's clear that. 74 divided by 0.2, we're going to get we're going to get exactly 370 flooring boards. So we need 370 of this piece of board here. Now, since one flooring board costs $38.25, then it's going to simply be 370 multiplied by 38.25. So let's multiply that by 38.25, and we're going to end up spending a total of $14,152.50. That's going to be the cost of tiling this particular floor here. All right, so at the end of the day, guys, you can see that the question was not as difficult. And if you thought it wasn't as difficult as you thought it was, then of course leave your thoughts in the comment section. I love to engage with you, my students. I've not been getting a lot of comments from you guys, but I do hope that you guys are in fact getting all the clarity that you need. All right, beautiful question there, I think. Beautiful question. All right, and this is in fact a past paper question. I did not alter this question, in fact. So this is a question I believe that was coming from, I don't remember the exact year, but it was earlier back in 2011, 2010, 2009, somewhere there or thereabout. I believe it was. If you guys know what year paper this was, leave it in the comment section below. Let's move on to part B of this question. It says the diagram below is a trapezium. In a second, I'm going to pull that diagram up for you. So the diagram below is a trapezium that was drawn using two separate shapes. The area of ADCB is 108 square meters. And the dimensions are as shown below. So here is the trapezium on the screen, guys. This is the trapezium that we're looking at. So this particular trapezium here, you can see that two arrows here. So we have this side that is parallel to this side. So we have 18 centimeters that is parallel to 9.4 centimeters, and then they are both connected by that vertical line, which we have an angle in the corner of 90 degrees here. So for those who have been doing mathematics or you have been in my live classes, you should be familiar with what a trapezium looks like. But this particular trapezium here was constructed by drawing not one but two different shapes, and these two different shapes evidently is going to be one, a right angled triangle, and two, it is drawn by a scalene triangle. So we're gonna call this triangle here S to represent scalene, and we're gonna call this entire triangle here R to represent the right angle triangle. And this is kind of a little thing that I usually do when I was, when I was learning math like you guys. For the first time, my instructor would tell me, hey, sometimes you got to split the diagram apart. Take the composite diagram and split it apart. So what I do encourage that you do is sometimes you can just go ahead and sketch it out separately so you don't get confused. All right. Now, it did went ahead and it gave us some requirements to complete here. It says that we should calculate the area of ADC. Let's have a look at what kind of shape is ADC. What kind of shape is ADC? Ooh, I actually did not label the diagram here, guys. So I believe, if I remember, just a second here, guys, I think this was A, I believe this was B, this was C, and this was D. Right, so I believe that's how I had named the diagram on the exam paper. So A, B, C, D. So they're saying that we should find the area of A, this is this point here, D, C. If we were to connect A to D to C, notice what it forms? It actually forms a triangle. Now let's redraw this triangle because it's not drawn exactly like what's on the screen. So it was drawn upright like that. So like that here. So if we label this side A and we label this side D according to the diagram and this one C, then we can safely say that they're asking us to find the area of the triangle. Now, let us consult back our notes. Let us sit in our exam chairs and we're going to think, how do we find the area of a triangle that all three sides are given? Aha! Heron's formula. Remember, that's a video that I had released on my channel earlier in the year. Okay, you can also find a link pinned to that video in the description of this video here. So let's pull up our Heron's formula here. Area is equal to the square root of S bracket S minus A, S minus B, S minus C. But before we can use that formula, we need to obtain the value of S, which is known as the semi-perimeter. And that's going to be A plus B plus C, and that's all going to be divided by 2. So therefore, let's kickstart it with that way. S is then equal to A, which we obviously know are going to be the individual sides. So any side can be A, B, and or C. So it's 18, 13, and 11. So that's 18 plus 13 plus 11 divided by 2. If we hop onto our calculator then and we say 18 plus 13 plus 11 equal, and then divide that by 2, we should get a semi-perimeter value of 21 centimeter. Now that we have the value of S, all we need to do is to substitute the value of S into the main formula, which is A equal the square root of all those other letters then. So then in the formula it says S open bracket S minus A. So that's going to be 21 open bracket 21 minus 18. It's going to be the same thing again, 21, but this time it's not going to be 21 minus 18, it's going to be 21 minus 13. And then for the final bracket, it's going to be 21 minus 11. Now, if you work these out separately, ladies and gentlemen, boys and girls, we're going to have 21 minus 18. That's going to give us 3. So that's going to be equal to the square root of 21. In that first bracket here, we're applying PEMDAS. And remember that bracket means to multiply. So that's going to be 21 times whatever is in each of those brackets. That's going to be 3 times again. That's going to be, let's see, 7. That's 8. And that's going to be 21 minus 11. That's going to be 10. All right. So if we go ahead and process 21 multiplied by 3, multiplied by 8, multiplied by 10, we should end up with a result of the square root of 5,040. Now, if we go ahead then, guys, and find the square root of 5,040, we will find the area of that triangle ADC works out to be 70.9. If some of you guys wrote down 71, it is still going to be acceptable. So we can say approximately 71 squared meters. I do encourage students, unless you are told to round off to a specific significant figure or decimal place, then you just simply write the first 3 digits, 70.9. all right, 70.99 is pretty much 71. So both will be acceptable. As I always tell my students, you know, an argument created over what I should or shouldn't write down will not change the price of rice. So 71, 70.9, thumbs up. Still perfectly correct. All right, beautiful. So that was not a difficult question at all. I believe that all of you guys could have gotten that question right. And I really do believe that I should have awarded you guys a little bit more marks for that. But it's fine. It was worth 2. Let's get on with it. Now, this word is something that Csec tends to use a lot. And you're going to find that this particular word here, hence, is a very key word that you guys need to get used to. And why I want you to get used to this is that it's such an important word. It really is what they say in English language is a transitional sentence, is a transitional word. So it really connects what was being discussed before with what is being discussed now. In mathematics, it connects the solution that you calculated before with the solution that you're intending on getting now. So it did say here that hence the length of the side marked X. We need to find the length of the side marked X. Now, this is interesting, right? We could use the Pythagoras theorem, but at the point of where I'm teaching my students, I would not have introduced the topic of trigonometry. So for my advanced students who may have gotten this far into the video and you felt like I could have used the Pythagoras theorem, of course, you would have gotten full marks. But considering that my students were not exposed to the Pythagoras theorem, we then had to improvise. Now, remember earlier in the question, it gave us a very valuable information here. And this is something that I've encouraged my students a lot. Practice to read the information, because here we're told that the whole entire shape ADCB equals 108. So therefore then, if we were to then go ahead and say, okay, so the area of the triangle plus, so let's put a plus sign here, let's put a red plus sign here. Both of these shapes together measures 108 in area. Now we already established that the area of this worked out to be 70.9. So I could simply find the area of this triangle here by subtracting the 70.9 from the 108. Remember, ladies and gentlemen, boys and girls, we are actually improvising, because we could have gotten the value of x by using the Pythagoras theorem, which is going to be c squared is equal to a squared plus b squared. But what if it is a case like here where you do not know, or you're not familiar with the Pythagoras theorem, or you've not been exposed to the Pythagoras theorem, where you and the Pythagoras theorem are not the best of friends? How else could we have done this? Well, you're about to see here. So if we can go ahead then and say 108 minus 70.9, let's hop onto our calculator. 108 minus 70.9, we will find that the actual area of the right angle triangle is 37.1 squared centimeters. No? So therefore then it is safe to say that the area of this triangle here, just a second here guys, so the area of this triangle here is literally, we can just safely say that this is 37 squared centimeters. Now, since as we have the area of that triangle to be 37, we can improvise then, and I gotta get to a new page here guys. Let me see if I can pull up a fresh page here, just a sec. All right, there we have it. Ooh, I pulled up a graph instead. My apologies guys, let's pull up a graph instead. Oh, is this a blank page? Okay, that's a blank page. So my apologies guys. Now, since as we have this area to be 37 and we have this side, remember we said that this side is 9.4. This is why it's important to also break the diagram apart. It does help you to keep your focus on one particular diagram. So here, this is 9.4. That's the base, and we're looking for x, which is the height, and we have the area. We could therefore use the formula for the area of a right angle triangle. Now, if the area of a right angle triangle is base times height divided by 2, I have this technique that I teach my students, especially because they are crash course students and they are topics that they would have not grasped, or topics that they would not have understood in their prior math classes that they've been to over the years. I have to use a technique known as the golden rule. That's what I label it as, the golden rule. And the golden rule is a rule where you write down your formula and then you substitute the values that you have into the formula. Now, we are aware that the area of that particular right angle triangle is 37. And then we know that the base of that right angle triangle we just established is 9.4. And we are in fact looking for the height, which is x. And we're going to divide that by 2. So we end up with an equation here that literally has one variable. Now if we cross multiply, or if you multiply both sides by 2, we'll end up that 74 is equal to 9.4 times x. And since the unknown variable to which we're looking for is connected to the 9.4 by a multiplication sign, we're going to use the opposite operation to get rid of our constant. So therefore then we can simply go ahead and divide 74 by 9.4, and we end up with an answer here of 7.87, and that's going to be equal to x. All right, so that is going to be the length of the side. Now, if you use Pythagoras theorem, and let me just quickly verify, if you use Pythagoras theorem, it may be a little bit off, because I constructed this question, but I have a difficult time in ensuring that the Pythagoras theorem was aligned with using the formula for the area of the right angle triangle. Now, like I said, it's very good to experiment when you're not under preparation for an exam. Had this question been structured by a group of mathematicians or different sets of persons, they would have made certain that the calculation was a little bit, would have been perfectly aligned. So I think for those advanced students who may be watching this video and you've gotten this far, if you try to use the Pythagoras theorem and you're not getting 7.87, then leave your thoughts and let me know what you think I may have done wrong in my calculation, because I'm sure. Let me just take a moment here and check. So I'm actually getting a far answer from what I had calculated earlier. So there might be some ambiguity in what I intended to do for those persons who use the Pythagoras theorem. But what I want to ensure that you guys get an understanding of is, should in the event that the question is perfectly constructed, then should the question be stated or structured like this? This is an approach that you should take. All right, so that's what I want you to take from this question. Not so much the ambiguity in the results, but I want you to also verify that this is the critical thinking that is required when the question is not written as straightforward as you expect it to. All right, so hopefully you guys got a hang of that question then. Okay, so let's go back to see what else they had asked us for. Is that it? 3 marks. That was it. All right, so that would have been question 5A and 5B. So for those of you guys who got that or you attempted question 5A, I hope that you acquired the full 15 marks. Let's then go ahead and move on to question 6A. 6A then says here that if an equilateral triangle ABC has side lengths measuring 3x plus 2, given that the perimeter is 42, we are to determine the area of the triangle. Wow, this is a nice question. Really nice question. And so as I was actually walking around observing the students, there was a bit of concern on the faces of some of the students. We did actually go through questions like this in class, but it may not have been exactly. And so the key in solving this question here is understanding, again, what is an equilateral triangle? It is in fact a triangle where all the sides have the same measurement. And now we are told that one of the length is 3x plus 2. Now, a lot of students right across the world, right across the Caribbean, whenever a student gets a question that is merged or affiliated with algebra, it usually tends to throw them off. And so you're not supposed to be thrown off by this, guys. Remember, you're being taught by the great Apex. I'm already giving myself a title, but okay, here we go, guys. So we have this triangle here. Some of my students must be laughing at me at the moment. So here we have 3x plus 2. Let's zoom this up a little bit here. So basically this is our triangle and all the sides have the same measurement. All right, and we don't really need a diagram for this. I'm actually just drawing a picture just to help you guys out so you see what I'm referring to. So basically what we're seeing then is that this side measures 3x plus 2. This side also measures 3x plus 2. And this side also measures 3x plus 2. So therefore, if we were to add up all the sides, what you're trying to say to us is that all these sides, when added together, will give us an answer of 42. Now let me see. Here we have it on here. So each side measures 3x plus 2. So therefore then I can do one of two things. I can go ahead and take the simpler route, right? Which is 3x plus 2 plus 3x plus 2 plus 3x plus 2, which is kind of redundant because if our algebra skills is up to par, all we had to do was just say 3 open bracket 3x plus 2, and that's equal to 42. we could simply just write a very simple equation like that and use our algebra skills. But there are some students that have recognized that if you try to make the question or take a slightly different approach, a more concise approach to the question, it will throw them off a little bit. Trust me, when I'm teaching these sets of students that I've met over the past 12 years, crash course students are students that usually depend heavily on the simplest approach to the question. Once it requires them to tie in a previous knowledge that they had learned, this is something that they have struggled with. So hopefully, as I go throughout this exam paper and throughout the whole entire course or entire year, you guys will develop over time the ability to be more concise and more efficient. Csec loves when you apply knowledge to you're working out. So here I'm just going to be using this approach down here, which is a very straightforward approach. So what we can do then is just use the 3 to go inside the bracket here using our distributive law property. 3 times 3x, that's going to give us 9x. That's the same way if we had said 3x plus 3x plus 3x, that's equal to 9x as well. And then we can simply see 3 times 2, and that's going to give us 6. That's the same thing as saying 2 plus 2 plus 2, which is still 6. So you can see it's the same result, and that's equal to 42. So if we say 9x then is equal to, now the 6 is connected to the 9x by an addition sign. So the opposite of adding is to subtract. So that's going to be 42 minus 6. So therefore 9x then is equal to 36. Now if we divide both sides by 9, remember that the 9 is connected to the unknown variable by a multiplication sign, because we know that 9x means 9 times x. Then the opposite of multiply is to divide. So x then would be equal to 36 divided by 9. And so x then works out to be 4. Is it centimeters? Did they say centimeters? I think they said centimeters. Let's double check on that. Did they say centimeters? Yes, they did. Right, it says 42 centimeters. So that's 4 centimeter. Now, remember that we had to find x in order to find the length of the sides, because we can't find the area of the triangle to which you're looking for if we don't know the exact measurement of the sides. So, therefore then, since this side is 4, since x is 4, since x is 4, what we're saying then is that one side is going to be 3 times 4. So it's going to be 3 times 4 plus 2. So 3 fours is 12, and 12 plus 2 is 14. So each side of this triangle here measures 14. Now, we could go ahead and find, I don't think we can use the Heron's formula, because remember earlier we said that if we have a triangle with all 3 sides, then we could use Heron's formula. But that's a long route. With an equilateral triangle, all the angles measure 60 degrees. So we could use our ability, our geometric ability, our knowledge, if we have it, about the equilateral triangle. Remember, crash course students, guys, for those of you guys who are watching and be like, oh, these questions are pretty simple, they're easy, I could do this. It is easy whenever you have the knowledge. Whenever you don't have the knowledge, a lot of students tend to find it very challenging to consult or search for data that is not in your archive. So, a student who does not know that in an equilateral triangle, all 3 angles measure 60 degrees, they wouldn't realize that they could use the formula A multiplied by B multiplied by the sine of the included angle divided by 2. So this could simply be a case where this is 14 multiplied by 14 multiplied by the sine of 60 divided by 2. Very easy approach as opposed to using the Heron's formula. Now, we've already seen the application of the Heron's formula earlier, so I don't think I need to demonstrate to you that it can be used. Of course, you would just add 14 3 times, which would be 42. You divide that by 2, you'd get 21.5. And then you'd subtract 14 from 21.5 3 times, multiply them, find the square root, and, of course, get the answer. But easier, 14 times 14 times, ensure that your calculator is in degree mode. So look at the top of your calculator. You should see a little d, or you should see the word, or you should see the abbreviation deg. So sine 60, if it's in radians mode, you will get an incorrect result. So therefore, this is going to be 169.74. Yes, 74. And then, of course, we haven't divided it by 2 as yet. So that's 169.74 divided by 2. Bam. We get the answer, 84.87. Now, what I want you guys to do is, since as the exam is over and you're now in a state where you're not under pressure, try to use the Heron's formula and let me know in the comments if you got the right answer. All right? Beautiful. Nice start to question 6. Let's then move on to question 6b. Okay. So then, last question here, well, second to last. The diagram below, not drawn to scale, shows an extracted sector of a circle. Interesting. So now we're looking at the circle. So the diagram below, not drawn to scale, shows an extracted sector of the circle with center O. Angle MON equals 63 degrees, and the radius ON is 11.7. We are asked to calculate the following: the length of the minor arc, the area of the circle, the area of the major sector, and the area of the shaded portion. So let's break this down, ladies and gentlemen. Let's hop over to our blank page that contains this particular diagram here. Beautiful. There it is right there. That's our beautiful extracted sector. Now, for those of you guys who haven't heard about a sector, or you've seen this for the first time, or maybe you've seen it but you never understood the concept of sectors, a sector is a carved out section of a circle. So what I do is, to get my students to understand and to pick up what a sector looks like, a sector usually comes in the form of a slice of pizza. So if you guys have ever eaten a pizza, right, you would know that a pizza, normally you put the pizza cutter in the center of the pizza and you'd slice towards the crust, and then you'd slice again towards the crust. So that slice would pretty much be given to one of your friends or somebody who you're eating with at the moment. So this is a pretty big slice because the angle here is 63. Now, a traditional pizza, I know that this information is completely irrelevant to the question. A regular pizza, if you were to cut it into 8 equal slices, would measure an angle of 45 degrees because the whole entire circle, which is a pizza, measures 360. So if you divide 360 by 8, you should get 45 degrees. So that is why earlier I said that this is a very large pizza because it's a very large slice of pizza because it has exceeded the usual slice degree of a sector of a slice of pizza. All right. So with that little bit of story there, let's get back to the question. It is a sector. If it did not state that it was a sector, you could easily identify a sector because a sector usually has a curve like that and 2 straight lines connecting the curve. That's one way to recognize a sector. And secondly, usually whenever they say that there is a center O, usually that is affiliated with a circle. So usually whenever you carve out a section of the circle and it has a little curved section here, then usually what happens is that it's a sector. All right, so let's get to the question then. We are asked to find the length of the minor arc. Now, this is what I love about CXC. There's just some points where you love CXC because they give you the formula that you have to use, and you're just sometimes when they really mess with your minds. I've seen questions where I kind of, from a teacher's perspective, I feel like the questions are easy, but then if you put your minds in the minds of a crash course student, a student who is trying to achieve a particular grade in math over the course of 8 months with limited or no knowledge of math, trust me, it can be a brain warming, brain exercising exercise. So, length of minor arc, you guys should have seen the formula at the back of the paper. Length of arc is going to be theta divided by 360 multiplied by 2 times pi times arc. No, times r. What did I just say? Arc? That's crazy. Let's get into it. So theta is going to be the angle, which is going to be 63 divided by 360 degrees, which is the complete degree for the full circle, multiplied by 2 pi r, so that's going to be 2, and we already know that pi has a constant value of one of two things, either 22/7 or 3.142. I like my calculator, so I'm going to always go for 3.142. All right, you don't have to put the 2 on it as well, guys. All right, I like to use the 2, no, not for any specific reason, but I just like adding on that extra 2. It gives me that extra accuracy in my answer. And then the radius, as was stated in the instruction, is 11.7, and as can be seen there on the diagram. So like I tell my students, at this stage of your mathematics practice or your mathematics preparation, you should be able to just go ahead and type everything into the calculator at once here. So let's go ahead. 63 divided by 360 multiplied by 2 multiplied by 3.142 multiplied by 11.7. Voila, your answer is going to be 12.866. I could just go ahead and write 12.87 or 12.9. Let's just use 12.9. 12.9 centimeter. So basically, what have we just calculated, ladies and gentlemen, boys and girls? We've just calculated the distance around the edge here. That is the measurement of that curve section. That is the arc. That's the minor arc as well. All right. Now, during my preparation of the students towards this exam, we had numerous conversations about minor arc, major arc, minor segment, major segment, minor sector, major segment, major sector. So there is always going to be that question that I, maybe CXC, maybe another math instructor is going to give you, that's going to try to tickle your brain a little bit. So have a look at this next question then. We're asked to calculate the area of the major sector. The major sector. Now, you might say to yourself in the exam, major sector. But I'm looking at the diagram and I'm only seeing the minor sector. What does he mean by major sector? Let us think. If we are, in fact, looking at the minor sector, which is the smallest portion of the pizza, it means then, using your imagination, and it's not going to be drawn properly, guys, but this is actually a complete circle that was not drawn. So notice how I'm kind of carving out a circle here. So not drawn perfectly. Hope you guys can see that. Here, let me just try to see if I can brighten it a little bit. Here basically is a circle that is incomplete. So what you're pretty much asking us for in this question here is to find the area of this missing portion around here. That's pretty much what you're being asked to find, the area of the major sector. Now, the sector formula doesn't change because it's the minor or the major. What changes is the angle in the sector. Now, what we have is the angle of the minor sector. So we need to calculate then what is the angle of the major sector. And so to get the major, we pretty much have to subtract 63 from the total revolution. And the total revolution in a circle is in fact going to be 360 minus 63. All right, so let's go ahead. 360 minus 63. The major angle is 297 degrees. That's pretty much what it is there. 297 degrees. Now, stick up in here, guys. I did in fact skip out a question. We're going to come back to this in a second. But as I was scrolling past, I realized that I did not calculate question number 2, which was the area of the circle. Now again, the area of the circle formula is provided to you by CXC at the front of your examination paper. On this paper, it was written at the back. So area of a circle is in fact pi times r squared. So therefore, area of the circle is 3.142 times r, which is 11.7, and then we're going to square that. So again, on the calculator, 3.142 multiplied by 11.7, and we're going to square that. Boom. Answer is equal to 430.11. We could say 11, or we could just say 0.1. So let's just use 430.1. All right, 111, doesn't matter. It's 430.1. We could even leave it at 430 if you wanted to. Squared centimeters. So I was moving a little bit fast there, and I skipped out to find the area of the circle. Now, again, guys, remember we spoke about that word earlier in one question where we stated that the finding the area of the, using the word hence, pardon me, this word, keyword here. A lot of students don't know the power of this word here, hence. And this word is so important in mathematics because it gives the, well, at least if I was a student having the brain that I have now, I'll be like, oh, okay, so hence means that maybe the answer that I just got here might be useful to the next question. Let us see. Now remember we stated that the sector formula is actually given, and the sector formula is actually theta over 360, and it looks a lot similar to the length of the arc formula. But with the length of the arc formula, we're actually multiplying by 2 pi r, but with the area of a sector, whether it be minor or major, is actually being multiplied by pi r squared. Now here's the power of the word hence. We now know that the new theta is 297 because we're looking for the major. So that's 297 divided by 360, and guess what happens, guys? The power of the word hence, using the word hence, having an understanding of the word hence. A lot of students have stated to me during practice that they would just go ahead and write down pi 3.142 times 11.7 squared. But guys, watch this. We literally just calculated pi r squared, and we got 430.1. So we could use this information here, boom, and transfer it over here, which is going to be 430.1. Easy, yes? It's a little bit less working out, right? If you guys would still like to go ahead and use pi 3.142 times 11.7 squared, that is also fine. But I believe Csec is I think Csec really admires a student who is able to say, hey, I did this calculation already. Why do I need to do it again? Just transfer my answer, and it's the same question. So 297 divided by 360 multiplied by 430.1, and guess what happens, guys? Hold on, I made a mistake. 297 divided by 360 multiplied by 430.1. Boom. Guess what we have, guys? We have the area of the sector, the major sector, that is. And that works out to be 354.83. 8 is fine. 354.8 is fine. Beautiful, beautiful, beautiful. All right. All right, so I hope you guys are in fact enjoying the video. I'm really trying to put a lot of energy into it, have you understand and enjoy the class at the same time, enjoy the review. Remember, math is fun. All right, sounds like a very cliche statement, but it is actually fun when you actually are looking at your mistakes. In fact, I hope you guys actually have your exam papers in front of you and you are looking at what you should have done, could have done, or simply just looking at what, oh my God, how did I not do this? How did I not think of this? a lot of reviews after my exam paper review videos, pardon me. A lot of students came to me and they would have said to me, Akeen or Apex, I cannot believe I made that mistake. I cannot believe that I actually understood what needed to be done and I didn't do it. So I get a lot of these because, of course, students will always come after the exam and say that the paper was actually easier than what they thought. No, we're actually trying to change the game here, guys, because a lot of Csec students, Caribbean students, are struggling with mathematics. If you guys are struggling with mathematics, you need to be subscribed to this page. You need to be following my TikTok and you need to be joining my classes. Stop failing math. Math is easy when you're being taught by yours truly. All right? Very, very easy. Tap into the class, subscribe, leave a like, leave your comment, do all that fun stuff. Okay? Let's get right back into the question. Going off on a tangent a little bit there, guys. Just going off on a tangent. But let's see here. So we are also asked to calculate the area of the... Okay, so we did that. Area of the major sector. Oh, the last one here, E. We are asked to calculate the area of the shaded portion. This is an interesting question. Calculate the area of the shaded portion. Now, remember that when a student is learning a lot of math, when you're learning a lot of math, there are just going to be some critical information that you guys are just going to forget. You guys are just going to forget it. And I usually ask myself why or how you forget these things, but then I put myself into the shoe of a student. I was a student. I would not have remembered this either ways. But with the aim and the objective of my channel, my aim here is to literally help you guys to always be able to find something in real life to connect to the math. So when you hear the word segment, what do we think about? Okay, we think about a patty. Or we think about the two-dimensional drawing of a melon. A melon? A melon? Yes. Remember that when you were back in primary school, your teacher would say, hey guys, this is a melon. And she would put some seeds here. So you'd see like some seeds here. And she would just say that it's a melon. Back in primary school. So these little things that we'll do to help us remember certain concepts is important. All right. Let us verify. I believe, did they say major or minor? Oh no, they said the shaded portion. So for this here, to find the shaded portion, we need to know what is the name of the shaded portion. And so we know that the shaded portion, in this case here, is called the segment. Now, the segment doesn't have an axiom formula, like a formula was designed to say, hey, area of segment equals that times that. We don't have that. This is where the intuitiveness comes in, the critical thinking outside of the box. So for this here, understanding that the segment is a small portion of the sector. So the segment is inside the sector. I hope you guys understand that. The segment is inside the sector. So there's some subtraction that has to take place here. But what exactly do you subtract? Now, if we were to look at this particular shape in a more breakdown form, you'd realize that, oh, let's zoom up here. The segment, and look at the shape here. Interesting. It's a triangle. So pretty much, to help you to visualize this better, it is the segment plus the triangle. So this part that is shaded in red plus the part that I've just scribbled out here, this part here that is shaded in blue now, it is those two sections that come together to make up the sector. Let's create an equation. Let us not rely on remembering the formula per se. So now we know here that the seg, all right, critical thinking, guys, seg plus tri equal sec. So the segment attached to the triangle will come together and form the sector. Now, we are looking for the segment. And because the triangle is connected to the seg, we can, by addition, we can just subtract. So it's going to be the sector, it's going to be the sec minus the tri. Didn't realize, guys, that I just used a very simple algebraic approach to deriving a formula for the segment. I hope you guys saw that. Anyways, let's get into it. So the seg here is equal to the sec. Ooh, do we have the area of the sector? Let's check. Let's check. Hence me coming to play here. We have the area of the circle. We have the length of the minor arc. Ooh, so here's what the trick is, guys. We actually have the area of the major sector. We have the area of the major sector. So for some students, you may have just been caught off guard by using the 430. Or by using the 354, pardon me. Now, if you do that, you're going to be incorrect, because we are looking for the area of the shaded portion, which is the segment, which is in fact the minor segment. I hope you guys understand the emphasis that I'm placing on the critical thinking here. I structured this question in such a way that I needed to see if you guys were thinking. That was the aim. And CXC does this a lot. Maybe not as complicated as I've done it here, but they do tend to, play with your minds a little bit to test to see if you're looking. So the trick or the setup here, or what I was aiming to set you up for, is to set you up to use this 354. So for the smarter students who were able to see through what I was doing, you then realize that the sector in this case is going to be the minor sector. All right, so how do we find the minor sector? We could go ahead and say 63 divided by 360 times 430. But since we're looking for the minor sector, we could subtract the major sector from the full circle. So we could say, all right, hopefully I'm not complicating the question, guys, and I hope you guys are following. All right, if I can take the area of the circle, all right, this critical thinking here. Let's have some fun, guys. So area of circle, that's the full entire shape, and we can subtract the major from it. If we take the major from the full circle, we'll get the minor. So area of circle minus major gives us minor. So the area of the circle we have calculated to be what? 430.1 minus the major is what we just calculated to be 354.8. There we have it right here. 354.8. 354.8. Okay, so if you jump under calculators here, 430.1 minus 354. Moving a little bit too fast here, guys. 354.8 will end up with 75.3. Now, if you guys would like to go ahead and say, all right, let's do it the other way. Let's say that we weren't thinking as critical as Mr. Peart. 63 divided by 360 multiplied by, type this in with me, guys, 2 times, not 2, it's pi r squared. Let's times it by 430.1. Guess what happens, guys? Aha! We get the same answer. 75.26, which is 75.3. So really and truly comes down to your critical thinking. Either ways will get you the right answer. All right, so that's 75.3. So the sector is actually 75.3 here. Minus, now we need the area of the triangle. Now, one of the formula, okay, so the formula that is used for a triangle that is inscribed in a circle, most times, especially if we are given the angle, it is always the formula A times B times the sine of theta. So see this formula coming back again, A times B times the sine of theta, A times B times the sine of theta. Interesting. A times B times the sine of theta divided by 2. So we could use that. There are some times when Csec gives you the question and they don't give you the angle. Interesting. So if they don't give you the angle, you may have to use Heron's formula, which they would have to give you the length of the chord, which is going to be here. They might have to give you the length of here for you to use Heron's formula. But most of the time, guys, because of how the question is structured, usually you're able to use this AB times sine theta divided by 2. So the AB would have been 11.7, which is the radius. So 11.7. Let's pull that up on screen so you guys see. So these are the two sides. This is A, this is B. And remember that they are both radii, and radii of the same circle are equal. So therefore, then we could simply go ahead and say, hey, 11.7, we could say 11.7 squared if you wanted to. So 11.7 times 11.7 times the sine of 63, all divided by 2. So let's type that all in. Don't have enough space, guys. If you guys would like to actually have the pretty much like the solution sheet, I could actually, well, I actually did it separately on some folder leaves. I could scan it and email it to you, so where it's a lot more organized and structured. All right, and guess what happens? It's not for sale, it's for free. So ensure that you are subscribed, all right, and you are following the page, you're following the channel to get access to this. So 11.7 times 11.7 times the sine of 63. Oops, I think I made a mistake here, guys. 11.7 times 11.7 times the sine of 63 equal, and then we're going to simply divide it by 0.98, or just to make it simple, guys, let's call it 61. All right, so that would be the area of the triangle. So there you can see then, if we can put the 61 right here, and then guess what happens, guys? 75.3 minus 61 approximately is 14.3 centimeter. Now I know that a lot of you guys may be saying to yourself, sir, why did you have to make the question so challenging? Why did you have to make the question so hard? Guys, remember that we are preparing for an external huge exam. We all know that Csec is a big deal in the Caribbean. If you can somehow prepare yourself mentally to deal with these type of questions that require you to really sit down and think, what if CXC was to send you an easier version of this? What do you think would happen? In my opinion, I think that I would run through it. Unless I really have like a panic exam attack or something, then that stops my brain from working. I mean, guys, I'm in the business of preparing students. I'm in the business of creating grade 1 students, not grade 2, not some students who wants to pass an exam. My channel is geared towards rebuilding, restructuring, and turning grade 3 students into grade 2 students, and grade 2 students into grade 1, and grade 1 students into distinction students that will go on to college. That is the aim and objective of my channel. All right, so that brings us to the end of that question. Let's double check to see if there's any more here. Remember, guys, if you are not yet subscribed to the channel, you need to do so right now. Subscribe to the channel and stay tuned. We are going to be posting 2-3 weeks of classes every single week leading up to the exam. You cannot miss. And if you want to see some behind the scenes footage of my students and I having fun, you can follow the TikTok page. You can also follow the Instagram page to see where my students get monthly awards. You can see the brightest students of this academic year. Lots of stuff is going on, guys, so ensure that you are in fact following all the platforms. All the links to my platforms will be pinned in the comments and in the description of this video. All right. Let's bring this paper to the end then. That brings us to the end of that question. We are now asked to calculate here. We're then asked to calculate then. Let's see here. We have this one algebra question here. So I had to squeeze this one in. All right, had to squeeze this one in. Right? Because I do have students who have they have topics that they prefer. So usually if they know that they can get 10 points here and they don't have to do this 5 points, they'll run to that question. So I have to make sure that in all my questions, I interjected a little bit of algebra. So depending on your decision, you may end up with a question that you really like, or you may end up with a question that you really don't like. Now with this one here, 12L, pardon me guys, it looks like 121, but it's actually 12L m squared. My students curse me all the time. Well, not curse, but they make fun of me whenever I write my letters. It is L, guys. Okay, so stop making fun of me. 12L m squared divided by, 12L m squared over 5x to the 4y cube divided by 2L4, I almost said it was 21. It's crazy. 2L4 M5 over 15x7y5. Now, algebraic fractions. Easy stuff, right? We spoke about that word easy. Easy is relative depending on if you have knowledge of the topic. So with this then, we're dividing fractions. And the fraction is algebra. Does the rules change when it comes to fractions? It actually doesn't. I had a student by the name of Cassian Fleming. She didn't really teach me, but she gave me a nice little approach. She said that she used what is called the KCF method. So, bless up yourself, Cassie. I hope you did well on this exam. KCF, it means keep the first fraction, change the sign in the middle, and flip the last fraction. Super easy. So 12, L, I'm going to change my L so you guys can stop laughing, m squared over, so I'm keeping the first fraction as it is, y cube. We're going to multiply, so we're going to change the division sign to multiplication, and then we're going to flip or invert the last fraction. So you could call it the KCI method, the KCF method. Some students, in Jamaica or in the Caribbean, I believe, KFC is like one of the huge franchise. So usually whenever our students think about KFC, they tend to think about fractions. No, they don't. They absolutely do not think about that. But yeah, you get what I'm saying, guys. Let's just have some fun here on the video. The KCF method is keep, change, flip. All right, so we're going to flip the last fraction. 15x to the 7 and y to the 5. I'm trying to be as funny, but it's not working out. If you guys think I'm a funny math teacher, please let me know in the comments. We try to make math as fun as possible here. All right, now that we have applied our KCF method, let's do some cancellation, guys. Here we go. So we have 2 into itself goes 1 time. Whoops, that's a large one. So, okay. Let's do all that over again. Okay, here we go. So 2 into itself 1 time. Perfect. 2 into 12, 6 times. Let's do the numbers first, guys. 5 into itself, 1 time. 5 into 15, 3 times. All the numbers are cancelled. Let's focus on the letters one by one. Let's focus on the L. We have an L at the top here, and we have 4 L's at the bottom. Therefore, one of the L's at the bottom has been cancelled by the L at the top, leaving us with L3 at the bottom here. Now, the correct way to teach this is to say, hey guys, if you're dividing, subtract the powers. But again, remember I told you earlier about crash course students. This topic is a topic of indices. A student is learning this, they're not thinking about indices. They've got to be trained to think that way. So the correct way to teach this, and then as you will find on a lot of math channels across YouTube, you'll find that teachers will say L4 divided by L1 will give us L4 minus 1, and that's L3. So to cut that out and to just make it simple, we say 1 L at the top cancels one of the 4 L's at the bottom, leaving us with 3 L's at the bottom, L to the power of 3. And we're going to use that technique, guys. So 2 M's at the top, 5 at the bottom. The 2 at the top cancels 2 of the 5 that's at the bottom, so we're left with M3. Now we have 7x at the top, and we have 4x's at the bottom. The 4x's at the bottom cancels 4 of the x's that is at the top, leaving us here with 3x's at the top. And finally, we have 3 y's at the bottom with 5 y's at the top. 3 of the y's at the bottom cancels 3 of the 5 y's that is at the top, leaving us with y3 at the top here. All right, and that's just more archaic, more common sense approach to the question, just to get you to the answer. Later on, if you wish to advance your concepts and your approach towards your calculation, of course, you can always, of course, follow my other page, which I'll be doing some college maths as well. So now finally everything has been cancelled out. We just simply need to write down what is left after the cancellation. Now we have a 6 here multiplied by a 3 on the other side, so that's 18. There is nothing left beside the 6 because the L is crossed out, the M squared is crossed out. Then we have the 3 that was multiplied by the 6, so we got 18. So we end up with x3 here. And then we have y3 here. Let's look at the bottom to see if anything is down there. The only thing that is at the bottom is the 1 and the 1, and 1 by 1 is 1, so we don't need to write the 1. And then we only have L3 at the bottom and M3. Interesting question. All my variables are risen to the power of 3. That is it, guys. That is it. All right, you could, so that would be the final answer, right? And you do have some other types of teachers that will tell you that the answer is 18x to the 3, y to the 3, L to the minus 3, M to the minus 3. Guys, don't worry about how we got that answer. Just know that this answer is perfectly correct. Beautiful. That brings us to the end of question 6A and question 6B. And that would bring us to the end of the video, with the exception that I gave my students a bonus question. So we did a couple review videos before this, right? This would have been, was this the third? I think, yeah, this was the third exams given to my students throughout the whole year. And we are, in fact, well, we ended the year for some of my groups of students, because I have different pools or different groups of students. For some of my students, I actually reached a topic that's called coordinate geometry. Now, all my students were provided with a link to a, in my opinion, self-praise is no recommendation, but I feel like that video was so exceptionally done. I'm actually going to repost that video. Yes, because it did not get the views that it deserved. So I'm going to take it down. I'm going to repost that video on the channel because that video was exceptionally done. If you guys are struggling with coordinate geometry, you need to check the link that is pinned in the description of this video and also in the comments. Coordinate geometry, part 1, part 2, and part 3. Now, as it relates to how many of my students actually watched that video before the administration of this exam, I can't say for certain. But in the results on your paper will tell me how many students actually dedicated the time to watching that video. If you had, this question would be a piece of cake. But if you didn't, now you can watch it. This is how the question is done. Bonus question worth 12 points. Students had the option to add this bonus points to their previous grade. If they wanted to add it to their previous grade, I would double the points. I did not tell them that. But if they wanted to add it to the current exam grade, they would only get 12 points or 12%. I'm sorry guys, I could not tell you. I wanted to see if you guys would actually approach the bonus question. But let's get into it, guys. Here we go. Given that a straight line is connected by the points -3, 5, and q, 3, -4, you're to draw the line xq for 1 point or 1 mark. So all we had to do here was plot the points. Now all my groups of students, except for a few, I did not teach them how to plot points. We hadn't gotten around to that topic. Oh well, let's get into it then. So I've already drawn up my graph here for you, and some of you guys are familiar with the Cartesian plane. All right, so the first point here is -3, 5, -3, 5. So -3 to the left, 5 up. So -3 to the left, let's zoom it up here. -3 to the left, All right, so I'm using a different scale because I'm using a slightly different graph. It's more minimized graph, but this is the best that I could find from the type of device that I have. So -3 to the left, 5 up. We're looking at landing at this very exact position here. Is that it? Nope, that's not it. We're actually one step over, so it's actually here. Right, so it's -3, up 5. Here it is, we're up, going up 5. So we are across from 5, and we are above 3. Okay, let's take those markers off. We don't want to see those. And then the next one is going to be 3, -4. So 3 to the right and 4 down. Interesting. 3 to the right, 4 down. 3 to the right, 4 down. So we're approximately across from here. Is that it? We're in line, we're below 3, and we're across from -4 perfectly. So this would be the point A, and this would be the point B. And all we had to do to get that one mark, guys, I hope you guys are not too upset with yourself. Oh, that's not a straight line, guys, but oh wow. That's the best that I could do here, guys. Okay, let's try to do it a little bit better. Ooh, that was nice, wasn't it? Perfectly done. So that was a straight line. Beautiful. Connecting A and B. Was it A and B, by the way? It was? Oh, no. It was X and Q. My apologies, guys. Not that it matters in our calculation anyways. So it's X. X and Q. All right. Beautiful. All right, so that's for 1 point. Should have given you 2 points for that. We are then asked to calculate the gradient of xq. Gradient can be calculated by using a formula, or we could use rise over run. Now, for those of you guys who are familiar with the formula rise divided by run. Oh, that's my Instagram page, guys. My apologies here. Okay, here we go. My apologies, guys. So rise over run. So the rise, now the word rise gives majority of the time, if a student has not grasped the concept, if they do even remember that the formula for gradient is rise over run, rise tends to give a feeling up. But in math, we have something called a negative rise and a positive rise. So if we are looking at the line xq as it is, then our rise would actually be negative. Let's straighten it here. All right, it's a little bit, it has gone a little bit below q, and then our run would be here. That's our run. So we'd have to count the distance here. Let's zoom it up here. I wish I had my other device, guys. It would have made this so much easier. So from X here, we're going to count 1. Oops. So let's see our rise. So that's 1. So from 5 to 4, 1, 2, 3, 4, 5, 6, 7, 8, 9. So it's 9 units coming down, -9. And the run, we're now going to be running, okay, running. So we are in line with -3, and we're going to be landing at 3. So that's running now. 1, 2, 3, 4, 5. Okay, let's check that again. So from -3 to -2, that's 1, 2, 3, 4, 5. Okay, so it's 5, 6, 6. 6 to the right. So we're going to the right, so it's +6. Now, if we reduce that, we'd end up with -3 over 2 or -1.5. So the steepness of this line is -1.5. Right, -1.5. Now, That's just one way of thinking. Of course, you could rise it this way and run it that way. You could do it like that as well. All right, whoops, you could rise that way, rise from Q and run towards X. You could do it like that as well. All right, but if you have an idea of the rise or the run, you'll know that it doesn't matter because you would rise positive 9 and you'd run negative 6 and you'd still end up with negative 1.5. However, though, the gradient can actually be calculated by using the gradient standardized formula of y2, y sub 2, not y squared, just in case you guys think that it's y squared, y2 minus y1 over x2 minus x1. Now, I did encourage all my students that, hey, guys, if you're on the graph, it doesn't make sense to use the formula because you're on the graph. Let's go right ahead, use rise over run. But there are some students that are, in fact, heavily dependent on a formula, right? Some students are not big fans of graphical topics, and so they always tend to move or gravitate towards the easier, so to speak, approach. Now, x2, y2, x1, y1, how do we get those values? They were given to us earlier. So here we'd have we'd have x1, not writing properly, guys. So we have x1 and we have y1, then we'd have x2 and y2. Fingers are a little bit big, guys, but you get the idea. That's x1, that's y1, this is x2, that's y2. So therefore then we can simply say y2 minus y1 would have been minus 4 minus 5. So minus 4, which is y1, y2, and y1 would have been 5. So if we go across here, so that's minus 4 minus 5. So minus 4 minus 5 all divided by x2 minus x1. x2 was 3. Sorry for switching the screens, guys. Using a completely new device. So x2 is going to be 3 minus negative 3. So 3 minus negative 3. So 3 minus negative 3. And if you do the math, you end up with minus 9 over 6, which is equal to minus 3 over 2, which is minus 1.5. Alright? So, no matter the approach you take, guys, you're still going to get the same answer. Beautiful. That is the gradient. Next, we're going to be looking at how to find the length of xy. And again, usually Csec doesn't provide you with these formulas, guys. So when I gave you the answers or when I gave you the formulas, it was literally to encourage you to do the bonus questions. Did you guys do it? I hope you did. Square root, whoops, let's do that first. So we have L is equal to the square root of y2 minus y1 squared plus x2 minus x1 squared. Here's the fun thing about this. When I was learning this, and I don't want to tell you a story, guys, but when I was learning this for the first time, I had a huge challenge in remembering so many formulas. It was crazy. So I had to find a very, very unique approach to remembering these formulas. And what I recognized, and I did remember the very first time I saw this, it wasn't a teacher or an instructor or nobody who showed me this. It was just based on just love for math and intuitive thinking and finding the easiest route to get these formulas in my head. What I did recognize is that the length of the formula, all right, the length formula is actually the Pythagoras theorem. And so what I recognize here is that if you were to go back onto the diagram here, right, and you look at this particular right angle triangle, you'll realize that we're actually trying to find the length of the hypotenuse, which is the red line. And so this would be your opposite and this would be your adjacent. So since as I already know that this length here is negative 9 and this side down here is 6, I could square the 9, square the 6, add them and find the square root. That is for the student who knows about the Pythagoras theorem. But I also realized that the length formula is actually the square root of the numerator of the gradient and the denominator of the gradient. So since as we already did all that fancy calculation in the gradient formula here, Remember all that calculation we did earlier? Y2 minus Y1 over X2 minus X1 here and here. There it is. We could simply just take the minus 9, square it, take the 6, square it. Easy, easy, without doing through all of that. So minus 9 squared plus 6 squared. Now, here's the part that sometimes, when a student has limited or no knowledge, they make this critical, heartbreaking mistake where they type minus 9 on the calculator and the calculator tells them it's negative 81. Remember, ladies and gentlemen, boys and girls, and all of you across the Caribbean, whenever you square any number, whether you're using your calculator or not, it's going to be a positive outcome. Now, if you choose to use the calculator, you've got to type what you see. You cannot leave out the bracket because negative 9 squared is not equal to 9, is not equal to negative 9 all squared. Let's explain this, because this is something that goes on YouTube a lot, right? Negative 9 squared means negative 9 multiplied by 9, which is equal to negative 81. That's what you're asking the calculator to do. But over here, you're asking the calculator to take negative 9 and multiply it also by negative 9, which works out to be positive 81. So you have one of two choices. It's either you're going to remember that regardless of whatever number it is, once I square something that's negative, I'm going to get positive, or you're going to remember to insert your brackets. One of two choices, ladies and gentlemen, boys and girls. All right? You have that option. So take the easier route, guys. When you square a number, it's going to be positive. Simple. All right? Beautiful. We're almost to the end of the video. I know you guys are tired. And I also know that you guys are entertained. So let's continue. Square negative 9, you're going to get 81. Squaring 6, you're going to get 36. And another reason why you will never have a negative here, most times when you end up with a negative under the square root, most times when you do that, or you end up with a negative under the square root, take for example here, you have negative 81. Let's say that you're not focused and you end up with negative 81, and you're going to add that to 36. Guess what happens? You get a negative 45. Now, when you try to find the square root of negative 45, guess what you get? Do it for me, guys, and let me know in the comments. You get a complex answer, or you get syntax error or math error. So you might be like, oh no, I did something wrong. What is happening? It's not working out. Not realizing that you have a negative number and you cannot find, well, you can find the square root of a negative number. It's a concept. It's a complex concept, which is an advanced level in math. So skip all that, guys. Stay focused. 81 plus 36 equals 117. So that's the square root of 117. And if we find the square root of that number, so square root of 117, guess what happens, guys? We end up with a very nice answer of 10 point. Oh, sorry guys, I think I'm having some issues with my screen here. We end up with an answer of 10.8 units, guys. Units, not centimeters, just units. Alright, I'm a little bit tired also, guys. So, it's a lot of energy it takes to really make this review paper entertaining. Midpoint of the line. Midpoint formula. Ladies and gentlemen, you guys got this. You guys have this. I know you guys got this. So, midpoint formula, guys. Midpoint formula. X. Am I supposed to be using my graph paper? That goes against all the rules of math. So let's pull up a fresh paper here. Whoops. There we go. Aha. So midpoint, capital M, is equal to x1 plus x2 over 2, comma, y1 plus y2 over 2. Alright, remember it's a comma between, guys, not a plus, not a minus, nothing funny. It's a point, so there has to be an X value and a y value. So x1, y1, we gotta go back to our previous page. X1, y1. So x1, let's zoom it up here. X1 was minus 3 and x2 was 3. So that's minus 3 plus 3. So minus 3 plus 3. So minus 3 plus 3 divided by 2. And that's going to be a comma. Oops, that's a huge comma. And then we're going to have over here 5 plus negative 4. 5 plus negative 4 over 2. Alright, so minus 3 plus 3 is 0 over 2, comma, 5 plus negative 4 is 1 over 2, and that's going to be 0, comma, a half. That's the answer for our midpoint. Now, if we go on our graph, and I'm happy that I have the graph pulled up, if we were to take 0 steps to our right or left, 0 is actually going to be here. That's going to be 0. Let's use our reading here. 0 here. That's 0. And take half steps up. Oh, this was a beautifully drawn graph. Oh, that's beautiful. That's a half. And guess what happens? We land exactly in the middle of the line. There we go. Bam, right in the middle. So that is the midpoint formula. That is the midpoint. That's the exact location of the middle of the line. Whoever, I think it was René Descartes that came up with the Cartesian coordinate system, a French mathematician. Beautiful. He made life easier for us in this modern world. And let's look at the final one, the equation of xq. Equation of a line. This is a very traditional formula that we know, that we all know, ladies and gentlemen. Y equal mx plus c. And this is far easier than you thought it would be. Because guess what happens, guys? We have the graph. So all we have to do was just look at the graph and we should be okay. Now remember that m, if you guys watched that video, m is actually the gradient. So y is equal to the gradient we had calculated earlier was minus 1.5, or better yet, minus 3 over 2x. And if we go on our graph and we look at where C is, remember, C crosses the y-axis. And guess what happens, guys? C actually is a half. Aha. There we go. It crosses the y-axis at a half. Positive a half as well. So we could just go ahead then and just type that in. That's easy. Actually gave too much marks for this. So could just, alright. Easiest way to do it. Because I have not taught that topic, and majority of you guys who may be watching this video for the first time have not actually gone through the entire breakdown of the coordinate geometry, I would love for you guys to check out the video that is pinned in the link, or sorry, check out the link that is pinned in the comments or in the description of this video, and watch the entire part 1 and part 2. You'd realize how I break down the equation of a line step by step, and there's some bonus extra stuff inside as well. Alright, and we are almost to the end of the video. Of course, I had to drop in that extra question here. I could not leave it out. I wanted to, but I could not. I had to end up ending the year beautifully in an infallible fashion. Is that a word? Is that a word? Emphatic fashion. That's the correct word. I think I'm going to start using this style of teaching. I think that students will enjoy, me just gimmicking around and having fun. Remember, math is fun, guys. It's fun. If you agree, leave it in the comments. Let me know your thoughts. Alright, let's run through this one really quickly, guys. We are going to go ahead and use a distributive law. That is going to be 3x. Oops, oh my lord. 3x here. So let's go 3x times x. Oops, 3x times x. That's not working. Let's try it again. 3x times x. Okay, that works. 3x times y. That also works. I would recommend that you do the expansion first. So I would recommend that you go ahead and do first with first. Oops. First with second. Then you do second with first, second with second. For those of you guys who do not know what this is, you can check out the foiling technique video for distributive law. That is pinned in the description box below. I have a live class that's about an hour plus. If you'd like to have conversations with me and listening to me talking to my students and hearing also my other students respond as well. Or if you want to just quicker approach, that link is also pinned in the description of this video. So you can go ahead and do that. 3x times x is 3x squared. 3x times y, that's going to give us 3xy. We're going to have this plus 4 here, open a bracket. Remember that we're going to be expanding those double brackets there. So x times 3x, that's going to give us 3x squared. X times y, that's going to give us xy. 2y times 5x, that's going to give us 10xy. And 2y times y, that's going to give us positive 2y squared. All right, then 3x squared minus 3xy plus, distribute the 4 right across the bracket. Then we have 4 times 3x squared, that's going to give us 12x squared. 4 times xy, that's going to give us 4xy. 4 times 10, that's going to give us 40xy. And 4 times 2, that's going to give us 8y squared. Simple enough. Group like terms, 3x squared matches with 12x squared, so that's going to be 15x squared. We have negative 3y here, positive 4y here, positive 40xy here. So let's do it. 44xy plus 40xy, that's 44xy minus the 3xy, that's going to give us 41xy. Yes, plus y squared. And that's our final answer. And that brings us to the end of the paper. Remember guys, most of you guys would not have been required to do all the questions. This video was completely done to accommodate every student that was actually going through the exam. Alright, so I do hope that you guys enjoy this new style of teaching. You can see I have a lot of emotions in my voice. I'm happy that I actually did the video before I marked the paper, because some of the results that I think I'm going to see are not going to be quite what I expect them to be. However though, remember, at the end of the day guys, it's very important that as a student, you have to not only be a student of mathematics, but you have to be a student of your own learning. You've got to understand how you learn. You've got to understand what you need to learn. You've got to identify your weaknesses and your strength, and you've got to strengthen your weaknesses and at the same time, if possible, strengthen your strengths. Remember guys, passing mathematics is easier than what you think it is. But for crash course students, you have to work 2 or 3 times of that of an average student who may be going through this course over the course of 3 years. All right, so I do hope that you guys enjoyed the video. My name is Apex Elenia, or preferably you can call me Apex or Akeen, that's fine. I would love to see you guys in the next video. Happy New Year to everyone. Merry Christmas. Well, Christmas has already gone, but Happy New Year to all of you guys, and I hope that you are all going to do well and come with a more positive attitude and positive frame of mind as we prepare you for your exams coming up in May of 2025. All right, and also for the students who may have done, oh yes, students who are in fact going or did the January exam, I will be doing that paper and releasing it sometime throughout the year. It's going to be very, very good as well. I have not released the 2024 May-June paper. I have the results, but I have not released the video. I will need to find a time to get that done. But in the meantime, in between time, have yourself a productive rest of the day. Awesome. Take care. Peace out, guys. Bye-bye.